Now I'm going to tell you something interesting, that is sublimation. Okay, sublimation. I taught you about boiling, I taught you about changed state of matter regarding temperature and all. And now I'm going to tell you something about sublimation. And sublimation is a very simple thing. You must have seen your mother putting naphthalene balls in the blankets during the summertime when you're storing the blanket aside. And when you open it in the winter, you see that the naphthalene balls are not there and neither liquid of the naphthalene balls. So where are the naphthalene balls gone? This is a process of sublimation. That means instead of converting to liquid, the naphthalene balls directly converted to gaseous state. Same happens with, dry ice. You won't understand like this. Actually, our favorite band, One Direction, was performing recently, and you must have seen some smoke coming up on the stage while they were performing, and the smoke was because of dry ice. People were just putting dry ice, and that was actually dried carbon dioxide. Because of increase in pressure, they solidified the carbon dioxide. As a result, it was solidified, and when it came to the room temperature and the pressure decreased, it automatically became gaseous instead of being liquid state. That's why it's called dry ice. Dry ice, as the name suggests, that it's not something related with water. It is dry ice, means ice to air. Now I'm going to tell you something about evaporation. You would say that evaporation is something you must have learned from your previous classes, and it's a very easy concept for all of us. If I ask you to distinguish evaporation from vaporization, how would you do that? You've just learned about boiling. Boiling is the other name of vaporization. So if we would distinguish evaporation and vaporization, then it would be something like this, and I'm going to do that. Evaporation and vaporization. So, evaporation is, first let's take up vaporization, because you all know about vaporization. 1, 2, 3, start. It's a bulk phenomena. Can happen only at 100 degrees Celsius. Isn't it? That's what we learned about this. Okay, now I'll explain evaporation in context to vaporization, so that you understand better. So if it's a bulk phenomena, it is a surface phenomena. And if it can happen at 100 degree, it can happen at any temperature. That means the exact definition of evaporation is that changing of liquid state into vaporous state at any temperature below its boiling point is called evaporation. Simple definition of evaporation. If you don't remember the definition, try to distinguish vaporization and evaporation, and you will automatically get to know it. And it's a very fast and noisy process, and it's a slow and calm process. That's not need to be written. I know that is smart enough. Now let's go on. Let's go. Okay. So we are here on factors affecting evaporation. First factor is increased surface area. How can it help? Let us read example from the NCERT. We know that evaporation is its surface. So You must have seen your mother drying up clothes. First she spreads it, then the sunshine comes, and then the clothes are dried. That means if you increase the surface area, then the process of evaporation is fastened. Okay, so first is done. Now let us discuss about an increase of temperature. Okay, now I'm going to introduce you to a new term, kinetic energy. What is kinetic energy? You must be wondering. If I run, if I dance, or if I swing myself, I possess a kinetic energy. Kinetic energy is energy possessed by moving objects. So the matter possesses kinetic energy, and that means that they are constantly moving. Okay, well, let's move on. And you know that kinetic energy is directly proportional to, sorry, I made the right sign. Directly proportional to temperature. That means if temperature is increased, kinetic energy would increase. And if kinetic energy would increase, the forces of attraction would decrease. As a result, a change in state of matter would occur fastly. Yes, we have done it. Now let's go on. A decrease in humidity. I'm going to give you a very sad example of mine. You see, if many girls are selected for the assembly, your chances of getting a chance to speak in the assembly decreases. Same is with the particles of matter. If there are more particles of matter in the air, then the chances of other particles converting from liquid to gas would decrease. This is why an decrease in humidity would affect evaporation in a positive way. So, ticked and ticked. Now let's go on. An increase in wind speed. Okay. Now what's this all about? You see, if a strong wind comes, it can carry you along. Can't it? Same is with particles of matter. If the wind speed is high, it will carry the particles of matter along with it, changing its state of matter. So, it's also done. And hence, we are completed how evaporation causes cooling. This is our last point. Now, you must have seen that if you ever use nail polish remover in some amount of nail polish remover got stuck on your palm, you feel very cold. But why so? Why? Okay, let's take up the heated particles as dots. As dots and cooled particles भैया क्या कर रही है बीच में ये देखना जूस पे क्या कोई नहीं particles as dash. I meant to do that dash. Sorry. Heated particles and cooled particles. So let's say this is our hand. It's not a good nice hand, no? But it's like, and this is our amount of acetone. So it's taking up all the heated particles from the palms are going towards it. All heated particles have gone to it. Oh my god, it's taking heat from the palm. And then what happens is that we are left with just dashes. That is only cool particles. That's why our hands feel cold. And hence my chapter is finished. But my dear friends, I'm going to tell you something that's very important. You should wear cotton clothes in summer because when you sweat is actually a normal phenomena. You sweat because when you sweat, that water gets evaporated from your body and as a result you feel cool. So we sweat. And when we have cotton clothes, the intake and outtake of the air can go through our clothes and it result in comfortability of us. So hence I'm culminating this chapter